In this video, we want to continue looking at linear inequalities that have absolute values and allow you to practice a couple of problems. So let me give you two very closely related problems. Let us look at 5x plus 2, the absolute value of which is less than 8. And let us also consider what would happen if we took the absolute value of 5x plus 2 and required it to be greater than 8. Go ahead and work these out. Now, in considering these problems, remember that when what is inside of the absolute value must be small, less than 8, it means that the number must be between, whatever this is, must be between negative 8 and, keyword and, 8. So we have a sandwich solution that's whatever, that 5x plus 2 must be between negative 8 and 8. So negative 8 must be less than 5x plus 2, but 5x plus 2 must be less than 8. So it's between those two values, and notice how I split it into two parts there. Let's continue. So in order to solve the left-hand side of this, I think it's fairly clear, we would probably want to subtract 2 from both sides. And when we do that, we have negative 10 must be less than 5x. Divide both of those by 5, both sides by 5, and negative 2 must be less than x. If we look at the other part of the solution, we subtract 2 from both sides, and 5x must be less than 6. If we divide both of those sides by 5, x must be less than 6/5, or 1 1/5. Now the key word here is that both of those things must be true. So we can rewrite this as negative 2 must be less than x, which must be less than 6/5. So up on the number line, if I were to graph out the solution, we're not going to include 2, negative 2, and we're not going to include 6/5, which is 1 1/5. It's going to be hard to draw in, but I'll put it about there. But we're including everything between those values. You could real quickly check a number in between, the easiest which is 0. If you were to insert 0 right there, the absolute value of 2 is what would remain, and that is clearly less than 8. So a quick check shows us that we probably have the right solution. Certainly having in between those values is good. Let's look at the other problem in red. So now we want to consider what is greater than 8. So if this needs to be greater than 8, the quantity inside of absolute values, we need it to be less than negative 8, such as negative 9. The absolute value of negative 9 will be greater than 8, or greater than 8. A number like 9 is going to be greater than 8 when we take its absolute value. So let's work out that solution. So we better have 5x plus 2 must be less than negative 8, or 5x plus 2 must be greater than 8. We perform exactly the same operations that we did before, and we get 5x must be less than negative 10. Divide both sides by 5. There are other ways to get to the solution. I think this is just the fastest. So x must be less than negative 2. Or, continuing down, we can subtract 2, 5x must be greater than 6. Divide by 5 on both sides, and x must be less, oh, I'm sorry, I was looking at the other problem that we just completed. X must be greater than 6/5. So if we were to graph this out, x has to be less than -2. What does that look like? We would come up here and we would say that it has to be less than -2, so that's everything to the left. Or x must be greater than 6/5. So notice the solution to what is in red is exactly the opposite of the solution in blue, because we reverse the inequality. So real quickly, numbers like 0 should make this false. If you substitute 0 in, you will in fact get that 2 is not greater than 8, so you get a false statement. On the other hand, numbers like -9 or 9 should work, and when you put those in, you will see that in fact you will get things that have absolute values greater than 8.